All right. While people are joining in, let's start with a brief introduction of our community. We're called Software Craftspeople India Community, and our fundamental goal is to connect people who have similar mindset of software craftsperson. The community itself is sponsored by a company Incubite. Incubite is a small service company which started last year, and we have been really focused on delivering quality software with the craftsmanship mindset, and that's what actually gave birth to this idea of a community where people with similar mindset can meet up and share knowledge with each other, right? So this is what the crust of our community is, and we are lucky enough to have people like people who have been in the software industry for the long time share their knowledge and experience with us. We have such a person with us today. Iván López today, as you all know, is going to give us an introduction to the Micronaut framework. He's a senior software engineer at Object Computing, and he's also been a JVM developer, loves Linux, and he organizes similar meetup groups like this in the Groovy space. So without any further ado, I'll hand over the control to Iván, and let's enjoy the knowledge and experience he's about to share. Iván, I'll leave it up to you now.
Okay, thank you very much for having me today here. It's a pleasure to be here with you, sharing something about Micronaut. So let me share my screen. Can you please hurry to turn off your mic? There is a little bit noise. Excellent. Okay, so let me know if you see my screen. Perfect. Yeah. So what I'm going to do today is I'm going to try to explain what is Micronaut, and I want to show you Micronaut in action. So the things that you can do with Micronaut in about 45-50 minutes. I have just a few slides to explain Micronaut, and then I will switch to the IDE to show you what you can do. So as I said, I'm Iván López. I work at Object Computing. OCI is the company behind both Micronaut and Grails frameworks. I used to be really focused on Grails in the past, and now I'm a core developer in Micronaut, and I also run the MadridGUG User Group. I'm based in Madrid, in Spain. And basically that's it. If you want to contact me, that's my Twitter. I will share my contact information at the end of the doc, so don't worry. So as I said, I'm going to explain in a few slides what is Micronaut. So Micronaut was created in 2018, or was released in the first version in 2018. And Groovy created it with all his experience from creating and evolving and maintaining Grails for the last 10 to 12 years. And he created Micronaut with a few things in mind. He wanted to create a new microservices framework for the JVM, not only microservices, right? Because you can do more things with Micronaut. And he wanted to be ultra lightweight, reactive. Micronaut is based on Netty, although you don't need to follow this reactive programming approach if you don't want. We do support the traditional servlet approach with Tomcat, Yeti, or Undertow. And for you as a developer, you can use any of the three main languages for the JVM for developing your application, so Java, Groovy, and Kotlin. And the key difference between Micronaut and other frameworks, traditional annotation-based frameworks like Spring, is that Micronaut does this thing called ahead-of-time compilation. So what is this? When you start your traditional annotation-based framework like Spring, right? When you start your Spring application, what the framework needs to do is at runtime read your bytecode, your code, and because it needs to try to, or needs to understand your application. So when you put an enable configuration, you put a REST controller, at component, etc., the framework needs to analyze that and cache that information into memory, so it knows how you have configured your application, how dependency injection needs to be done, etc., etc. And the problem with that approach is that when you have a real-world application that has code, that takes time because it needs to analyze everything at the start time, and that takes memory because the framework needs to cache all that information into memory. So what Micro does is the same, but at compile time. That means that when you compile your Micronaut application, the framework generates all that meta information it needs to really understand your application. So when you start your Micronaut application, the framework doesn't need to do pretty much anything because everything was pre-computed ahead of time. It only needs to basically resolve the environment, the configuration, and that's it. So with this, what you get also is that you don't need to have a framework that does reflection. So Micronaut doesn't use any reflection, runtime proxies, dynamic class loading, dynamic bytecode generation, nothing like those techniques that are traditionally being used in all those kind of other frameworks. Although in these times, frameworks like Spring have moved to do more stuff at compile time. So they are now, or their performance is better than it used to be a few years ago, right? So with this approach, what you have with Micronaut is that your applications start really fast and you have a low memory footprint, right? So another thing that we wanted to focus on Micronaut is that this thing that we call natively cloud native, which means that for 2021, 2022, when you create an application or when you use a framework for creating applications, you as a developer wants a lot of things out of the box for you, right? So we provide a lot of those features. So discovery clients, centralized configuration, HTTP client, distributed tracing, distributed configuration, integration with a lot of third parties, libraries. You can deploy to Kubernetes, you can run on Docker, you can do a lot of things. And we provide integration with a lot of those things, so you don't need to worry about that. You just need to use them to solve your problems. Another thing that we do is that we also are focused on serverless, right? We support this serverless approach. So you can deploy your Micronaut applications to AWS Lambda, to GCP functions, to Azure functions, and they work really good. Also, we have this toolkit called Microdata, which is, if you are familiar with Spring, you probably know Spring Data. So this works the same approach, but having in mind this ahead of time compilation. This means that when you use Microdata, you define your access to the database with an interface, right? You have a user repository interface, and you have a method like find all by name. And that is translated to select a star from user where name equals whatever. So what the Spring does is implementing that at runtime, and what Micronaut does is implementing that interface and pre-computing all your SQL queries at compile time. So when you run your application again and you access the database, there is really, really low overhead because everything has been pre-computed, and the only thing that Micronaut needs to do is basically bind the parameters and run the queries. So this is a lightweight framework or toolkit for accessing the database. We have support for GraalVM out of the box since version 1. I don't know if you are aware of GraalVM. I will talk about that during the talk. I will show a demo. You just need to keep in mind that GraalVM works with Micronaut since version 1. So Micronaut is open source framework, Apache 2 license, no strings attached, so you can use any way you want. We have released since October 2018 that we released 1.0. So now in next month, it will be 3 years since the first release. We have released like 70-ish releases. The last stable release was 3.01. That was released like a couple of weeks ago. And a month ago, we released Micronaut 3. We have moved a lot of things. We have changed a few places or a few things in Micronaut since the last Micronaut 2.5. So if you start a new application, I encourage you to use the latest Micronaut 3 branches. And we have like more than 200 contributors. A lot of features have come from the community. As I said, Micronaut is open source, and we work with the community. and some people have submitted amazing things for different modules, and we have even modules that are maintained by the community. So basically that's it. What I'm going to do now, if I find my mouse, so I'm going to switch here, and I'm going to show you what you can do with Micronaut, right? So if you want to create a Micronaut application, one thing that you can do, you can go to this launch.micronaut.io, and here you can configure whatever you need for your application. So this is the default, a Micronaut web application, but you can create a CLI application, a gRPC, function, or message-driven. You select your Java version, package, the different version you want, language, build tool, and framework, right? And you can see here with features, you can add any of the features that we have. And as you can see, we have a lot of them, and I mean a lot. You can see the scroll bar. So we have support for views to generate HTML, the discovery, a lot of things regarding to serverless, as I said, for security, Reactor libraries, Rabbit, Kafka, JMS, Micrometer. So there is a lot of things. So you can say if you want to create an application with JDBC, you can select it. Or if you want also, I don't know, Postgres database, you can do it, right? So you select that, and you can preview what we are going to generate for you for Gradle or Maven, and you can generate a project, download it directly, or even push it directly to your GitHub account if you want, right? So this is one way to create an application. The other way is to install our CLI client. We have a command line tool for Mac, Linux, and Windows, and you can create your application here. So let me create an application. And so by default, if you only say mn create app and the name, what Micronaut is going to do is create an application with Java and Gradle, but you can change that, and JUnit for testing. But you can say that. So I'm going to use Spock for tests, and I'm going to use, actually I'm going to use Java 17, but we officially don't support 17 yet on the CLI, but it works. So I'm going to put 16, and then I will modify the build to use 17, which was released, I think, like 3 days ago, right? So I'm going to create the application, and basically I open the application on my IDE. And then I'm going to show you things you can do. So I'm going to change this to use 17. And I'm going to change also this for 17 and here. I have Java 8 by default because Micronaut is still built with Java 8. So I need to make sure that I don't use any other features of the language. That's why I use 8. But if you use Micronaut for creating applications, I encourage you to use now 17 because it was or it is the new LTS. And if you cannot use 17 yet, at least you should use 11, which is the previous LTS version. So this is our build. It's pretty much the same for Maven. It's a little bit verbose, but we have our own application plugin for both Maven and Gradle, and it takes care of a lot of things. So what I'm going to do, I'm going to start just writing code. I'm going to create an Encrypt controller. So if you are familiar with Spring, this will be pretty common for you. So you have a controller, and then you have a get, and I am going to say encrypt text. And this will return a pollo that I'm going to create, encrypt text, right? Let's create this. Expected. I will explain this later. So private final string text and a getter, right? So if you use, for example, Kotlin or Groovy, you don't need to do create getter and setters. If you use Java with Lombok, you don't need to worry about all this boilerplate code. But I'm using just plain Java. And here, what I'm going to do is like encrypt this text, right? But as I don't have really time to do a proper encryption, what I'm going to do is just, my encryption is going to be to reverse the string, right? So this will be encrypted, and I can use bar, and then I can return this, return new, my message, encrypted, right? So what Micronaut is going to do, you return a pollo, but Micronaut is going to, because we live in 2021, and by default we create JSON APIs, right? So Micronaut is going to serialize this pollo to JSON using Jackson, but you don't need to worry about it. It will do it automatically for you. So the next thing I'm going to do, I'm going to create an HTTP client to be able to interact with this controller and to test it. So I'm going to create my Encrypt HTTP Encrypt client. It's going to be an interface, and I'm going to annotate it with a client, and I'm going to say this is a client for the root URI, which is the same I use for my controller. And I'm going to push here the same method signature with the same annotation. And again, what Micronaut is going to do, it's going to implement this interface at compile time for us. So we don't need to worry about it. It will do everything to implement this, the right interface, do the marshalling and everything. And now that we have this, what I'm going to do, I can get rid of this. I'm going to create a test, encrypt controller specification. So this is an Spock test specification. If you use JUnit, it will be pretty much the same. I prefer Spock. Spock is a testing framework based on Groovy. You can totally use it for testing your Java or Groovy applications. I prefer Spock because for me it's way more powerful than JUnit 5. But you can easily translate this test to JUnit. So what I'm going to do is I'm going to annotate this test with at Micronaut test, because with this annotation, what it allows us is it will start an embedded server with all your Micronaut code, and it will allow me to do dependency injection in my test with at inject. So I can say encrypt client, and then I can actually write the test. Test encrypt controller. And the test is pretty simple. What I expect from this test is that when I call my controller encrypt method saying something like hello world, and I get, remember that this returns a pollo, this is my message pollo that I created. So when I get the text from that, I expect this to be this string encrypted, which in my case is reversed, right? So it will be something like this, probably. So let's run the test and we'll see what happens. Come on, Cli. Oh, it failed. Yeah, well, it failed because I don't know how to reverse the word, right? I did it wrong. It should be DLRW. Probably it should pass now. Yeah, it passes. And as you can see here, the test took a little bit more than 500 milliseconds. And in these 500 milliseconds, what we did was starting an embedded Micronaut server, an embedded application, and send a real HTTP connection with our client that we injected to the server and do the marshalling and unmarshalling. But as you probably don't believe me, and probably shouldn't, what I'm going to do up here, I'm going to set this. I duplicated the test, and I'm setting here the HTTP client log level to trace, so we can see all the traffic there, and you will see what's going on under the hood. So this is what happens. We are sending with our HTTP client a GET request to this URL. By default, Micronaut starts on port 8080, but for tests, we start on some random available port. So this is in this case, and we send the request, encrypt hello world, accept application rate, JSON, response, you can see 200, and then the content type of the response is application JSON, and you can see even here the body, right? And this is the body because in my message pollo, we have this text property or field, which is this one, and the text has been reversed. And as you see here, Micro do everything for you, the marshalling, the JSON, and you don't need to worry, right? You can work with your Java pollos, and it will work for you. And what I want to show you is that the first test took 600 milliseconds, but the second one only took 17 milliseconds. It's the same test, and this is because so in the in the first one, we need or basically we need to wait until the JVM starts, do the class loading and everything. But in the second one, which basically everything is up and running, we only need to send a real HTTP connection and a real request. So as you can see, having full end-to-end integration test is really, really fast. And what happens sometimes in the past is that we developers don't write too much integration or end-to-end tests because they are slow. And we prefer to use unit tests, mocking a lot of things because it's fast. So with Micronaut, you can see that you can write integration test or full end-to-end test, and they are really fast, right? So you don't need to worry too much about writing unit tests. And please don't get me wrong. I'm not saying that we shouldn't write unit tests. We need to do it, but when it makes sense. But when it doesn't make sense, it's easier and faster just to send a request to the controller, the same as you will do when you deploy this to production and test it, right? So let me remove this and comment this out. So what else? By default, Micronaut uses Netty for the server, and it runs everything on the Netty event loop. This means that you shouldn't write blocking code code that blocks the Netty event loop, right? So let me show you this. If I put here thread get a name. So let's run again a test, and we will see that the thread is one of the on the Netty event loop. It is here, right? Default non-blocking IO event loop. But if you, and this is fine for this code because we are not blocking, but if from this code we call another call, or we access to the database, or we send an HTTP request to another place, this method will block the Netty event loop, and you don't need to do that. So for fixing that, what you need to tell Micronaut is, this code is blocking, so please move this to another thread pool so it doesn't block Netty event loop. So you can use this execute on annotation, and you can say, please run this on the IO thread pool so you don't block the Netty event loop. So if I run it again, you will see that now the code is IO executor, right? And this is really important because we see from time to time issues and comments on our GitHub channel saying, when I send an HTTP request, it fails with a timeout, and I don't know what's going on. And pretty much always, or most of the time, is because you are blocking the Netty event loop. So for this case, we don't need to worry now because we are not blocking anything. But just keep that in mind. What else? I said that Micronaut is reactive by default if you want. So you can use any reactive library. For Micronaut 2, we were shipping RxJava 2, and it was used internally in the framework, and we were exposing RxJava 2 for clients or for applications. And for Micronaut 3, we've moved to Project Reactor, and we are not exposing that anymore. It's an implementation detail. So this means that you as a developer need to choose between RxJava or Reactor if you want to use a reactive framework. So what I'm going to do, what is my build.gradle? I'm going to add the Reactor dependencies because this is what we want to use. And you don't need to worry about this, right? If you already have an application and want to introduce a feature like this, like Reactor, the best way to know what to do is going to launch. You go here and you select, okay, I want to add Reactor. And instead of creating a project or previewing, you can click on this div button, and you will see a div between an empty application and the thing that you selected. So as you see, these two dependencies are necessarily, and this links to the documentation, and that's it. So basically, in this case, you only need to add these dependencies, and you now have the Reactor feature available for you. So with that, what I can do is I can go to my controller and I say, instead of returning my message, I want to return a mono of message. And I need to change this mono.just. I also need to change my interface. So this will be mono again. It needs to have the same signature. And now I need to modify my test because you can see IntelliGate's complaining here because now I'm not returning a message. I'm returning a mono. So the easiest way to fix this for test is basically block, right? for a real world code, if you are using reactive and you block, you are not gaining anything. Probably you are doing it wrong. But for a test, it's totally fine to block, right? Because you don't need to subscribe or do those kind of things. You just block until the request finishes and you get the response. And you can see the test still pass. And we have converted this to a reactive application. So the next thing I'm going to show you is this. I have here my business logic in a controller, right? But we don't do that. We don't put business logic in controllers because we cannot share it. And we cannot unit test it if we want. Or we cannot test it in isolation. So what I'm going to do, I'm going to create my encryption service. I'm going to annotate it with that singleton. And I'm going to move my business logic here. One of the different things for Micro 3 is that we have moved to the Jakarta inject or the Jakarta annotations. In Micro 2, we use JavaX inject, but because of the legal issues with the JavaX namespace, that they are owned by Oracle, blah, blah, blah. So we have switched to Jakarta. Everyone is switching. It's the same. You just annotate with a singleton, and this will create a Micronaut bin for you. If you are migrating from Micronaut 2 to Micronaut 3, you can either replace all your imports, or if you don't want to replace them, you can add the JavaX dependency and continue using the JavaX namespace here. So with this being created, what I can do now is I can inject it. So private final encrypt service. And here I can just return my encryption service, encrypt text. Right? Let's run the test again. It's important to have test. So when you introduce new code and you refactor everything, you know that it still works, it passes. And as you can see, if you come from a Spring background, you're familiar with this. Constructor injection for my dependencies. You can also do field injection like I did here for a test. For me, for a test, it's fine to do field injection, but for production code, our best practice and our recommendation is to always use constructor injection, right? Don't use field injection. Every time you do that, a kitten dies. And with this, it's better because with constructor injection, you can have your dependencies as final. No one will be able to modify them. And you can, the only way to instantiate this is with the right dependencies. So, and now finally that we have created these microservices or this microservice that encrypts a test. What I want to do is I want to be able to consume from another service. So what I'm going to do for doing that, I'm going to introduce you the service discovery. We are going to use console for that. So I'm going to add the console dependency and the console configuration here. I'm in console config, right? So don't worry about it. If you create an application out of the box with this feature, it will be there. And I'm going to start console in a Docker container. And now the next thing I'm going to do here is I'm going to set up this server port to -1 because I want to be able to start more than one instance of my application on a random port. So I'm going to run my application directly from my IDE. You see, less than 1 second, it starts on some random port, and the application has been registered in console with this name. And now I can change this in IntelliJ, allow parallel run, and I can start a new instance. You see, I'm using Java 17. Oops. And this started in another port. So now I have, if I open, what is it? Where is my? Yeah. If I open localhost 8500, which is the console UI, you can see that my encrypt service is being registered in 2 different ports, right? So we have now our microservices up and running. And what I'm going to do, I'm going to create a new one. Because when you have more than a microservice architecture, you have 1, 10, 100, whatever, you don't expose those microservices to your clients, right? One common pattern is to have one entry point, one kind of gateway, and everything is done through the gateway. You put the security and you put everything on gateway, and then gateway that communicates to everyone or whatever. So this is what I'm going to do. I'm going to create a new gateway, and I'm going to pass the reactor feeder, because we already saw it, the discovery console, because I don't want to add all the configuration manually. I'm going to use OpenAPI, and I will explain later. And again, Java 16. So let's open the project. Let's change this again to use here 17. And here 17. Right. So this gateway is going to be the entry point to our microservice architecture. So I'm going to create an API controller. And I want to expose this in this URL, API /, and I'm going to say this. What this means is that if I define API version anywhere in configuration, that will be used. But if not, by default, I will use the version 1. And what I'm going to do, I'm going to cheat a little bit. I'm going to copy these two classes from one project to the other. And I'm going to also copy this, right? In a real world application, you will probably create a Maven or Gradle multi-project build, and you will probably share the Pollo or the client or a few classes. But here I don't have time to do that. So the Pollo is the same. And in my client, what I'm going to say, so this is not going to be now a client for the /URI. This is going to be a client for the service called Encrypt service. Because remember, this is the name used by the other microservices to register in console. So Micronaut is going, when we use this HTTP client, Micronaut is going to ask console, do you have something named Encrypt service? And console is going to send the URL and port, and Micronaut is going to send requests to that URL and port. So here I'm going to inject my Encrypt client, client, and then here. And I think probably that's it. I can start my application. We will talk about the OpenAPI later. So this application starts on port 8080. So I can now go here and say localhost 8080 API v1 encrypt hello world. As you can see, it works, right? My gateway is sending an HTTP request to one of my encrypt services and get the return back and marshals and does everything, right? And as I have two instances running, every time I reload the page, I send a new request. The Micronaut HTTP client is doing a round robin balancing out of the box. But you don't see that because it's the same output. So what I'm going to do here, just to show you, in my encrypt service, I'm going to inject private final embedded server. And I'm going to show here something like from embedded server to get port. Let's start again a couple of instances. Port 53776 and 39962. So if I go back here, 39953. And you can see every time I reload the page, I get a response from one of the microservices, one of my backend microservices. If you don't like having this HTTP load balancing by default, you can switch that. You can configure it with a few things, and you can always implement your own strategy based on whatever you want. But by default, this is a nice default, because if I start here a new one and a third application, then it will be available like that. You can see the 27. So now we have 3, and if I stop this one and this one, then I only have 1, and that's the one that replies, right? So another thing that we have in this HTTP client, I'm not going to show you today, but you can read about that in the documentation, is what happens if my backend, in this case my encryption service, is not available. By default, it will fail, right? Because the HTTP client won't find anything. But one of the things that you can do is implementing a fallback, which is a code that will be executed when the microservice is not available. This is useful because you don't want that error propagate through all your microservice architecture. So for doing it, check the docs, but it's pretty simple. You only need to basically create a new service annotated with @ fallback and implement a common interface with your client and that service, and that's it. And Micronaut will do the wiring, and if there is no backend available, it will use that fallback from there. Okay, so now let's talk a little bit about the Open API feature I added. I don't know if you are aware. You may know. I have only. Let's start one of these at least. So I don't know if you are aware. OpenAPI, you may know as Swagger. It was Swagger a long time ago. But with Swagger or OpenAPI, you can define, or it's a way to document your APIs. This is useful because we don't work in isolation, right? I'm creating a backend API that returns JSON, but you will probably have another clients that needs to consume this API, or you have a front end developed with with Vue or Angular or React or whatever front-end technology you want, and you want to document your endpoints. So one way to do that is using OpenAPI. And as you see by default, if you go back again here and select OpenAPI, what it does is basically add a few dependencies. It creates these annotations, and it adds the dependency on the annotation processor scope to our Micronaut OpenAPI implementation and the Swagger annotations. And that's it. So with this, without doing anything else, we are already generating an OpenAPI definition or specification for your application. In this case, we only have one controller with one endpoint. And during compile time, you can see here in the Swagger directory that this was created. This is the OpenAPI specification for this service. And this is created at compile time. So you don't need to worry about maintaining it manually. So we can expose this to clients, and to do that, what I'm going to do, let me add some configuration here. This is called OpenAPI config. So what I'm doing, using Micronaut can serve static resources. So what I'm saying is anything in the class path in the Swagger directory, expose it in this URL, and in this, expose it in this URL. Because I also want to not only expose the YAML file, but I want to expose the Swagger UI. So with this, it will be exposed, but I need to tell Micronaut OpenAPI to create the views, right? The Swagger UI HTML. So I need to create this file, OpenAPI properties, and I need to say Swagger UI enabled true. We can also support RapidDoc and another UI, another templating that I don't remember. You can configure this in more ways. So with that, let me get rid of this. So I start my application. Micronaut compiles again, right? And I can go here, for example, here, and I can say localhost 8080 Swagger gateway. And as you can see, this is the same YAML, so it's exposed, but now also the Swagger UI HTML is there. So you can see it's consuming the same YAML, the same one as here. But this is a nice way to interact with your application. We have API v1 encrypt. It's a GET request. It receives a text. It returns a JSON like this. This is the pollo. I can even try. So I can click try out, and I can say hello from Swagger UI. I send the request. You can see here also the core if you want to send it on your terminal, and you can see the response. And I can send more requests. I think I only have one backend available. Let me start another one. So I can send more requests, and you can see how the port changes, right? So it's a nice way to document your API and also to interact with your API without doing anything else or without needing anything else. And as you saw, the only thing I did was adding the dependencies. And Micronaut does its best to try to create your OpenAPI documentation. But this gets better because we can do something. Sorry? So what we can do, we can use, for example, a Java doc, and I can say encrypts plain text receive as a parameter the plain text, the encrypted text. Right? So I add the Java doc. Let's get rid of this so we don't have any problems there. We restart the application. We go back here, reload, and as you can see, my Java doc is included now in the OpenAPI specification. Encrypts a plain message, the plain text, so everything is there. But you can do it even better because by default, as you said, we are not taking advantage of any of the Swagger annotations, but we can do it. For example, if I go here and I said the schema example, so you with a sample you say you put an example of this value that will be taken from here and put in the documentation. So this will be the reverse text, right? So if I write, if I say hello, the reverse text will be like this. So let me this and restart it. Now we can see, hopefully, that in my response, you have an example, right? Hello. So when I work on Micronut applications, what I usually do is I don't put Java doc on my controllers. What I do is use the OpenAPI, the Swagger annotation. So I say here operations and everything, because you can describe your OpenAPI spec as you want. You can define the return type. By default, we return 200, but what happens if you send something that it's not found and you want to document here that you have a 404, or this is secure, and what happens when you don't have permissions to access this and you need to return a 401 or 403 or whatever, right? So my advice is that you can start just using Java doc, but if you want to really document your OpenAPI properly, it's better to use the Swagger annotations. We have a lot of documentation in the Swagger module, so I recommend you to take a look at that. And what else? Yeah, so this is running, I think. Let me check it. So I will leave it is running. And the last thing I'm going to show you in my Encrypt service is I'm going to use, I'm going to convert this application to a GraalVM native image. So for those of you that are not aware, GraalVM, no, this one, sorry. GraalVM is a polyglot virtual machine from Oracle Labs, and it has a few things. But what I'm going to do today, one of the pieces in GraalVM is this native image generator. So that allows to convert a Java application to a binary, to a native binary of your target platform. Means in my case, I'm running Linux. So after that, I'm going to have a binary that works on Linux, and it doesn't have any dependency on the JVM, right? You can do it for Mac and Windows, so don't worry about that. And the advantages of having a GraalVM native image is that it's a binary, so it's a native binary. Like if you have a Golang application or a C++ application, it's a binary like that. It starts really fast. It consumes way too less memory, and I said it doesn't need any dependency to run it. So you don't need to do anything else on your Micronut application. This is Encrypt service that I created from scratch at the very beginning of the talk, doing just Encrypt app, because our Maven or Gradle plugin does everything for you. So what I'm going to do is from the command line, I'm going to run. Well, you need to do one thing first. You need to switch to a GraalVM Java version. So if you are using SDKman, you can use any Java, any GraalVM version. So the latest one is 21.2, and there are flavors for Java 11, 16, and 8. But as I need 17, what I'm going to do, I have this one compiled from source code, but you don't need to do that. You can go here, GraalVM developer releases. So they publish a new dev release every 2-3 days. This was from 2 days ago, so you can download the one you you need for your Linux or Windows or Mac OS. You install it, you define your Java home, and that's it, right? And this so this one, if I do this Java version, you see it's 17, but it's GraalVM 21.3 -dev. The stable 21.3 version will be released in a month or so. So you can do this, as I said, for 17 in 1 month, and you can download one of the development versions. So now that I have this GraalVM version, Java version installed, what I can do is let's run this task. Gradle W, native image. But before doing that, I want to show you this. So this is going to create a native image, and the problem with native images is that they take time to build, and they need memory. So you see that I'm using now almost 14 gigabytes of RAM. This is my CPU. I have 6 cores, 12 threads, right? So my CPU is not doing too much, and my memory it's fine, my memory consumption. So I'm going to run this, and I want to take a look at the memory. Well, now Gradle is running, so it took like 1 gigabyte, but now it's creating the native image, right? So it started in around 15 gigabytes of RAM used. And as you can see during this process, the memory consumption, this red line, is going to be increased. And the CPU also is going to be increased. This will take around 1 minute, 2 minutes. It depends on your CPU, and it depends on your RAM. But this takes time. What this is doing is from your application entry point, which is the main class, right? From this entry point, GraalVM is analyzing everything, all the reachable code, and included that code into the final native image. And all the code that is not included, or sorry, all the code that you are not using won't be included in the native image, right? Because it doesn't make sense to add dependencies that you don't need. So if you imagine that you create a plain Java application and you use import Java util list, but you don't use any map or any other thing from collections, then all that code from Java won't be included in your native image. Now you will see here after this a compile phase, and during that time you can see now that pretty much all my threads, my core threads, will be to 100%. The memory now it's 22 gigabytes of RAM, and I said this is going to take a few more seconds. So one of the things about this is that you probably don't want to run this to create a native image in locally every time you modify your code, right? You should do this probably on CI when all your test passes. Then you create a native image and you deploy it to your QA or staging environment or whatever, right? Because this takes time. So let's wait a few seconds. So now it's going to, the compile phase, it's going to finish. So you will see now, yeah, the CPU now it's getting less use, and I have 22 gigabytes used, and now it's going to, yep, so back to 14. So around 8 gigabytes, from 6 to 8 gigabytes of RAM to build the native image. It took almost 2 minutes. And here in this file is the native image. So I can say this. So it has created a binary 62 megabytes of size in disk. That you may be thinking that is too much, because probably the fat jar of this application, it's like, I don't know, 20 or 30. But keep in mind that for running the fat jar with Java -jar, you need to have the JVM installed. And with this, you don't need to do this. You can install a very small Docker container with Alpine Linux or something like that, and this will work. So let's run it, and you will see it started in 94 milliseconds, and this is like kind of slow. I've seen startups around 20-25 milliseconds, and the application registered itself in console if this port 2467. So I can send here or from here, it doesn't matter. I can say hello GraalVM 2467, and this is the other one, right? And I have more than one running, but this is my native image. So the nice thing, as I said, what is it? Oops, there's an error. So it started really fast. It consumes way less memory. So this is really helpful if you want to, for example, in a in a serverless environment, or when you want to scale up really, really fast, because even if Micronaut applications on the JVM start really fast, this is less than 1 second, and it's like that because I'm sharing my screen and I'm running more things. But usually this application starts in around 500 milliseconds. So even with that, this is 940 milliseconds. Sorry, 940 milliseconds. And this one was only 94. So basically, one order of magnitude faster starting native images, right? So you can start even more if you want. 51 milliseconds now, and then I have another one up and running, available here for returning, for getting the traffic on my app. So if you want to go this road, please keep in mind that we still, we support this from the very beginning, and we work with the GraalVM team to make sure that this works in every release of GraalVM. We have a lot of tests to make sure that Micronaut works really well with GraalVM. But I encourage you to take a look at the documentation and the GraalVM docs, because it's not everything is like this fun, right? Sometimes there are things that don't work on a native image, because when applications on libraries do reflection, that needs to be configured, and there are a few things that are not working yet. So it's like kind of I don't know if experimental is the right word, but it's not like fully battle tested as the JVM itself, right? So keep that in mind that you can do it. I'm not saying it doesn't work. We know that it works. We have a lot of clients and people using Micronaut with GraalVM on productions, and they are quite happy with that. But you need to properly test your native images to make sure that they work. And yeah, I'm running out of time, so let me just finish my slides. So as a summary, with Micronaut, you can, as a developer, build your applications with the main 3 languages for the JVM, Java, Groovy, and Kotlin. You can use whatever you want. Micronaut itself is written everything in Java, except the integration with Groovy and Kotlin. Micronaut is natively cloud native. I show you a few things like the discovery, the service discovery, the HTTP client, but there is a lot of things. You saw there all the features that you have available in our launch web page. If you come from a Spring background, you will feel like at home. The dependency injection works the same, but it's done at compile time. And you will feel that the programming model is pretty much the same as the one that you are used to it. One of the key features of Micronaut is this ahead of time compilation. There is no reflection or runtime proxies, no dynamic class or bytecode generation at all. With that, Micronaut application starts really, really fast with a low memory footprint. And at the end, developers are happy, they are productive, because they can use a new tool to solve and to focus on the real world problems, and they don't need to worry about the framework itself. So there are a few resources: our Twitter handler, the main page, micronaut.io, the documentation. This one, micronaut.io/documentation, is the entry point to all the documentations in all the modules. You will see that there are like, I don't know, we have like 50 different modules. Micronaut.io documentation. So this one is the Micronaut itself, and you can see here Elasticsearch, Micrometer, gRPC, Jackson, Microdata, Micronaut MongoDB, GCP for cloud, our Maven and Gradle plugins, Flyway and liquid-based migrations, MQTT, Rabbit, Kafka, the reactive stuff, all the security. This is a really important module. Everyone is using Micronaut. A lot of people is using Micronaut security. So you have seen, you will see this is the Micronaut main core docs. There is plenty of docs here. The next one is our GitHub main repository. In Micronaut projects organization, you will find everything. Guides.micronaut.io. If you want to start with Micronaut and don't know what to do, go to this web page, and you will find here guides, which are like a small documentation with a sample code that works, and you can download it and you can run it. And the guides explain how to do something in like 15 to 30 minutes. Focus on just one topic. So imagine that you want to secure your application with JWT tokens, right? So you have one guide, and we have guides written in pretty much all the languages. This is not always the case, but we try to write the languages the guides in the 3 languages, and the build tool. So if you want to use Kotlin and Maven, you can do it, right? You can open this guide, and this is the version for you. And we explain here, it's updated always for the latest version of Micronaut. We explain JWT in this case. You can download a zip with the whole code running. We test the code to make sure it works. If you want to create this application from scratch, you have here the filters you need to do. And then we explain how to configure everything, how to create the authentication provider, how to secure your controller, and how to test it properly. So if you want to know to learn about different pieces of Micronaut, guides is a really, really good place to start. We have like 50 guides or so, and we add more guides every few weeks or so. And the latest one, Gitter im.micronaut framework, is our Gitter channel. Gitter is like Slack. So the development team, we are there. If you have questions or you have comments on anything, join us, and we will be more than happy to answer your questions. And that's it. This is my contact information. If you have any questions or whatever you need, don't worry. Reach out to me. Send me a Twitter. My DMs are open. You can reach me, or you can send me an email, or whatever you want. So I think that's it. I don't know if we have time for questions.
All right. Thank you very much, Iván, for the presentation. I think we have one question in chat. Does Micronaut support metrics and distributed tracing for microservices?
Yeah, Micronaut supports metric and distributed tracing. We have support for both Jagger and Zipkin for distributed tracing, and we support Micrometer with like, let me quick share my screen again. We support Micrometer with like a ton of different backends. So if you go to launch, can you see my screen, right?
Yeah, we can.
So you can say, for example, Zipkin, and you can say Micrometer, and you can see Podpix, Atlas, Azure Monitor, CloudWatch, Dynatrace, Elastic, Graphite. You can set your things to Graphite, so you don't this. And you can see the different things, the management endpoints. So this is the management endpoint also exposes a few endpoints, like the health endpoint, which is helpful to know if your application is up and running, an info endpoint, a beans. There are a few endpoints, and then we have the Micrometer Graphite and everything for Zipkin and the configuration you need. So yeah, we support a lot of them, and if you need a different backend that is not there, let us know, and we will be able to use it, or even better, submit a PR. We are always open to get PR from the community. This is great.
Even I had another question regarding the CLI. I saw that on Micronaut launch you have option for creating command line applications, and I think you are using Pico CLI in the behind the scenes. So, like, and with support for GraalVM, like, is it possible to generate like on the fly generate CLI applications for say Windows, Mac, and Linux, which have like the fast startup times that you are showing right now? So, say a complex CLI like the Micronaut CLI itself, I think that's built on top of Pico CLI, if I'm not wrong.
Yeah, that's a great question. So yeah, we use Pico CLI, and yeah, as you said, the Micronaut CLI is built on top of it with all the Micronaut support. And yeah, actually, the Micronaut CLI is a very good example, because the one that I show you, that one is running GraalVM. So if you use SDK-man and you install Micronaut with, it doesn't matter, Windows, Linux, or Mac, you will get the native binary built with GraalVM of our CLI. So yeah, it works totally fine. And yeah, we've done a few things for some clients or for some internal stuff with creating CLI applications, because it's really with Pico CLI, it's really easy to create CLI applications, and then with GraalVM, they start really fast, and you don't need to worry about basically anything else. One thing for those of you that don't know about GraalVM, as I said, you need to, if there is some kind of reflection on things like that, you need to configure that. So if you plan to deploy your application with GraalVM, use Kotlin or sorry, you use Java or Kotlin. Groovy is not supported because Groovy heavily depends on reflections. On reflection, you can configure or generate all the reflection configuration for Groovy, but it's tricky. We don't do that out of the box, so it won't work. If you plan to do that, choose Groovy or sorry, choose Java or Kotlin for that.
Yeah, thanks a lot. So it would be really nice to see Java and Kotlin on the CLI. So yeah, definitely gonna try it out.
Awesome. Let us know if you have any problems or questions.
Okay. We have one question from Sachin Verma. In comparison to Spring, in which all use cases Micronaut performs best?
Well, regarding performance is always tricky, right? Doing the right performance comparison, because even though the frameworks are pretty much the same and they solve similar problems, they are not. So it's always hard to compare apples to apples. But basically, usually the memory consumption is lower in Micronaut applications because everything I explained, and the startup time usually is lower with Micronaut. But so there is no like we wrote in our blog post in our so if you go to micronaut.io, we wrote a blog post some time ago comparing Micronaut, Spring, and I think Quarkus, and Graham did a talk or a live recording like when we released Micronaut 2 a year ago, comparing the three of them, and also configure Micronaut the same way as Spring, because by default we use YAML for configuration, but Spring uses properties. So YAML has a little bit of overhead. It's not too much, right? But if we want to compare apples to apples, we need to remove the YAML dependency and add the properties, right? To just to be the same. And so that's why it's difficult. I recommend you to read there are, so for example, yesterday I saw that this guy from Okta, I don't remember his name. Mark Rabel, right? He's a Java champion. He works at Okta. He wrote a comparison from Micronaut, Quarkus, and Spring Boot like some months ago, and I saw that yesterday he updated that to the latest versions of the frameworks. So I recommend you to take a look. He put he shared the source code of everything, so you can run the test manually on your laptop to check how they work for you, and you can tune your application. So I think that's it. It's like usually the performance is better, but it really depends on your case. Maybe for one specific thing, Quarkus is way or Spring is way better because whatever reason, and for other things we are.
Okay. Respecting your time, if you have time to answer one more question, it's from Utsav. What's the next major milestone for Micronaut?
So we kind of release one major version per year. So we released Micronaut 2 in July 2020, and we have released Micronaut 3. That was because of vacation and holidays and things. We were a little bit of delay, but we released Micronaut 3 mid-August. So we can expect, or you can expect, Micronaut 4, the next major version, around summer next year. But before that, we released minor versions around every 6 or 7 weeks. So probably by the end of this month, Micronaut 3.1 will be out. And then 6-7 weeks after that, probably, it depends because now we are close to Christmas and there are holidays. So but by that time, there will be Micronaut 3.2. So in these minor versions, we take really serious the semantic versioning, which means that for minor versions of the framework, we don't break binary, we don't break compatibility, or we don't break backwards compatibility, or we try to, right? Sometimes to fix a bug that we didn't implement correctly because some RFC says something, we need to do it, but it's always documented and there are not too many cases of that. So basically, every 6 weeks a minor version and then a few patches version. You can see that we have 3.0.1 now, and probably before releasing another one, next week we will release 3.02 patches. So my advice is that every time we release a new patch version, upgrade it. It's just a matter of updating probably your Gradle properties or your POM XML with a new version, run your test, and it should be fine. And when we release a minor version, also try to upgrade, because there shouldn't be any breaking change, and you keep up to date with the framework. Because if you wait too much, it will be more complicated to upgrade from. If we know people there are people still using Micronut 1.3, so upgrade from 1.3 to 3 will take a few more time. Not too much, right? It's not a huge thing, but it's always easy to do it incrementally every few weeks instead of waiting 2 years to do the upgrade.
Awesome. I don't see any more questions. Thank you. Thanks a lot, Iván, for joining us and sharing knowledge with us. And I think we had on average 45 to 50 community members with us as well. So thank you all for tuning in with Iván's talk. Up next month, we are having one more expert talk from Sapan Parikh from eClinical Work. So if you are interested in that, stay up to date with our meetup page. That's all from our side. Thank you all for joining. Thanks again, Iván, for hosting a talk with us.
My pleasure. Thank you. Thank you very much for inviting me and for having me today. And I really hope you learned something new today. And if you, as I said, if any of you have any questions, feel free to reach out. Thank you for having me.
Thanks a lot, Iván.